All right, let's start some math for 5-4. I was way off, 5-4. Today we're talking about triangles and things that we can tell just by looking at a triangle. So the big idea here is that triangles are possible as long as two sides added together. So we're going to say sum of two sides is greater than the third side. As long as that's true, all is well. Okay. All right. So what does that look like in this example? You're going to ask yourself, is 8 plus 17 greater than 24? And you're like, oh, but why that combo? Couldn't I try something else? Sure, you can try 17 plus 24 has to be greater than 8. You would also have to say 8 plus 24 has to be greater than 17. Those two are automatically true because both of these numbers are larger than that number to begin with. So adding it to something bigger is going to get that. This number is automatically bigger than this number, so it's already there. So really, we just have to check that the two smallest sides added together is greater than the biggest side. Okay, so 8 plus 17 is 25. Is that greater than 24? Yes. So triangle is possible. Running out of room there. What about this one? Two smallest sides added together greater than the other side. 3 plus 3 is 6. 6 is not greater than 7. So no, not a triangle. You could also try this. So if you wanted to grab a ruler and make 3 sides and make the 3 sides, this says meters, that would be a very large triangle, but let's say we made them inches. We made a 3-inch, a 3-inch, and a 7-inch. And we tried to put those together to make a triangle, like connect all the little points there. It would not work. Okay? And the last one here, that's actually a 41. It's kind of hard to see. But my two smallest sides are 35 and 7. We want to know, is it greater than 41? Well, 42 is greater than 41, so yes, triangle is possible. All right. Of these 4 squares, this second square here is the most difficult, but once you get in the pattern, it's pretty easy, so don't lose me here. It's the same idea as far as, all right, we have 2 of the sides. We need to make a third side. I don't know what the third side's length is going to be, but what are all of my possibilities? Okay. Could you cut out a 3 centimeter and 11 centimeter and then figure out what's the smallest and longest possible things? Yes, that's a lot of work, and it's not exact. So let's work on exact. To do that, we're going to think of the 3 combinations of adding the sides together. I could add the 2 sides that we have together, and I know they have to be bigger than the third side. So I know that 14 has to be bigger than x. So x has to be smaller than 14. What's another combination? I could do 3 plus the third side, and I know that it has to be greater than 11, because that's the other side. Solve for x. So 11 minus 3 is 8. So x has to be greater than 8. Then my last combination is 11 plus x has to be greater than 3. And since we're talking about measurement, we're talking about positive numbers, anything is going to be bigger than 3, any positive number here. So we don't even really have to consider that one. We look at these 2. And mathematicians are lazy, so we're going to write this as one math sentence that says a lot without us having to actually type it out, okay? So x has to be between 8 and 14. So notice I put x in the middle, small number first, big number last, and then I use the less than symbol for my final answer. So the numbers that would work for this example are between 8 and 14. So 9 works, 10 works, 11 works, 12 works, 13 works, 8.5 works, 8 does not work. Okay? So try those next two, same setup, same way. So 28 plus 31 has got to be greater than the third side. 28 plus x has to be greater than the third side of 31. And then 31 plus any number is already going to be greater than 28, so I don't really have to math there. Here I get 59 is greater than x. Here I subtract 28. So I get it has to be greater than 3. We have a way larger variety here. Our range is between 3 and 59. So x has to be between 3 and 59. All right, to save time, I'm leaving 6 for you to do. Always check back in class notebook to make sure you got it. All right, these last two are super easy, super quick. So here we go. Smallest angle is always opposite the smallest side. Largest angle is always opposite the longest side. I should probably use the word shortest instead of smallest here. If you wrote in pen, it's okay. Not a big deal as long as you know what it means there. Here's our example. So 17, 20, 24. 17 is the shortest side. So that means straight across from it has to be the smallest angle. Okay. 24 is the longest side. Across from it must be the largest angle. So if I'm ordering the smallest to largest, I order angle C, then angle A, then angle B. Because A was in the middle. 20 is in the middle of 17 and 24. On the opposite end of that, the same is true. The shortest side is always opposite the smallest angle. Longest side is opposite the largest angle. They tried to trick you here because they only gave you 2 angle measurements. But remember, to find the third one, they have to add up to 180. So I just do 180 minus 59 minus 53. Calculate that. You may use a calculator, no big deal. 68 degrees is this other one. That is my biggest number, so this must be my longest side here across from it. 53 is my smallest angle, so this must be my smallest or shortest side. Okay, so if we're ordering the sides from greatest to least, the greatest is EF, the smallest is DE, and the other one is in the middle, so DF. Please notice that image is not drawn to scale because if I actually measured, I'm going to guess that the bottom line there is the longest. Okay, that just means that the angles and sides are not drawn to scale. So you still pay attention to the information given. Don't try to get your own ruler out. All right, this concludes 5-4 notes.